All right. Good morning, everybody, and welcome to day 9 of 100 in the 100 days of Python from Replit. So here we are. Let's go down here. Day 9. So we went from 38,000 people down to 34. So I was talking about this yesterday. If we look, 194,000 people started on day 1, and just in 9 days, we are down to 34,000. So we're just going to continue on here. We'll hit go. And it looks like we're going to be learning about casting. So let's move our video up. These are about 20 to 25-minute lessons is what they say. Some have been about that. Some have been a little bit longer, but that's probably just because I'm slow.
It's day 9 and we're going to deal in casting. No, I'm not going to teach you some magic like Harry Potter. We're going to look at how we can use numbers in an effective way. Okay, until now you probably tried using numbers in some of your questions and some of your answers, and you can't do a lot with them other than just checking that the user's typed in a number in exactly the same way that you've asked. Well, that's a bit of a lie, because if statements don't just support our double equal symbol, they support this entire range of symbols that you can see at the moment. These questions are called inequalities. We've got not equal to, so if both boxes are different, that will trigger the if statement. We've got less than, greater than or equal to, less than or equal to, all the classic inequality questions. But if you try to use any of those inequalities, greater than, less than, the way we're doing it at the moment, it just won't work. And the reason for that is because the way input has been working behind the scenes is that input always assumes that what you type in is text. In other words, gets stored in a variable with quotes around it, assuming it's a string. Now, that's a reasonable assumption on the part of the computer because it's being typed in with a keyboard, and a keyboard, as you imagine, turns out to be mostly letters. But in certain cases, we want the user to type in numbers, and we want the computer to specifically refer to them as numbers. And the way we do this is with a process called casting, where we explicitly tell the computer what you're expecting to be typed is going to be a number. Now, just a little warning, we do get some crashes if the user tries to type anything else. That's perfectly normal at this point, don't worry about it. Okay, we're going to start with this piece of code that I've written very simply to incorporate the different equality symbols in the if statement addition. In other words, I've written a question that says, what score did you get in our game? Any number over 100,000 should make the computer say winner. Anything less than that should cause it to say try again. Why don't you go and try it and see what happens, and then we'll do it together.
All right, so let's do it. All right, so it says if statements support more than equals the support inequality symbols as well. Remember that the greater than, lesser than, or equal signs used in math back when. Well, they're back again, but this time a little bit different. So we've got an example here for equality and inequality, and then we've got this sample. So let's run it. Okay, and let's just say my score is 100. And we get an error. So it says line 2, if my score is greater than 100,000, not supported between these instances. Okay, so we're probably going to learn how to fix that today. We'll just run it though, and let's take this score to see how it should work. We're still getting that error, so let's just see what he says.
Okay, so hopefully you saw the same sort of thing happening. Let's say that I got just an amazing score, well over 100,000. it completely crashed the program. It didn't even not work. It completely crashed it. Now let's try and decipher that error message a little bit. It says the greater than symbol is not supported between instances of string and int. Well, what does that mean? Well, have a look at the way that I typed a number in. I put nothing around that number at all. I typed that number in absolutely as it comes. That's because to a computer, a number wouldn't have quotes around it. And that's quite interesting because that means when input works and the number goes in, the computer puts quotes around it. And as far as we're concerned, in our variable box, that is the text version of that number. How do we tell the computer, hold on, sunshine, that's a number? Well, it sort of depends on what kind of number it is. There are two types of number that we need to care about, an int and a float. An int is a whole number, in other words, there's no decimal part to it, and a float is a number that we expect to have a decimal. It only matters what you pick here if what you're expecting to be typed in is going to be different. I want a whole number for this score, so I'm going to use int. And what I'm going to do is in front of my input, I'm going to type in int and place the entire input in brackets. Now, of course, the order at which the computer is evaluating this expression is important, and it does the brackets first. So the first thing it's going to do is this. It's going to put your score on the screen and take that value in from the computer. Now, at this point, it still has quotes around it, so it thinks it's text. What the int part does is it says, hold on now, sunshine, this isn't text. This is a whole number. Can you convert it for me? And the computer goes, oh, it is a whole number. Wow, here, have the number back. And essentially just removes those quotes and hands it back to you. Then it stores it in the variable myScore as a number. When we come down to that if question again, it's able to compare two numbers. And if one of them is bigger than the other, it will trigger the if statement. Let's try.
Okay, so let's copy this in with that int and see how it works. Okay, so if I was to enter 3.142, is exactly, let's run it again. And I'm going to put 3.149. Try again. Okay, so that worked. You did it. We are casting and that input as a float, which means that they're expecting a decimal point. The code will not crash if we put a dot, a decimal point, and the numbers after it are the signify a decimal point. Okay.
Try it. Well over 100,000. And I'm a winner. Let's check it works though. What if I had such a bad run that I got minus 100? It works perfectly. We are now able to take any input and turn it into a whole number with int. What about a decimal then? In this example, I'm doing exactly the same thing. I'm asking my user to type in pi to 3 decimal places to see if they remember what it is. And all I'm doing is casting that input as a float. That means I'm expecting a decimal. And so it won't crash if I put a dot and then the numbers after it. Let's test it out.
Okay, let's test this here, hit run. Okay, so there's definitely, it's the issue with that. Let's look. Okay, so okay, invalid syntax. We're getting the invalid syntax. I'm not seeing where, because if you look, like this is what actually ran, and I don't see the difference. What if? Oh, I do see the difference, actually. Actually, I don't know. Let's try this. That was wrong. All right. Actually, I don't know. So let's look here. We forgot the second closing at the end of our input. Remember, on each line for every open bracket, there needs to be a closing input. Hmm. Yeah, that's not right. But I don't see on the one that ran where the closing input was for that. So let's go back. We know that this worked. It's here. It'd be that one. All right, cool. So that was it. It was here that we needed the closing statement, the ending input. All right. So then what is the error? Let's try this one. Again, it would be the statement, right? Hmm. We would need a beginner. All right. Okay. Then what do we have here? Print. Exactly. That looks right. Is there supposed to be a space here? We would need that closing statement. There it is. So we're missing the quotes, right? So this should say exactly. All right. So now we will run it. And that's right. Okay. 3 point. or 2. All right, so that was it. Okay, so let's hit this answer. And it's saying we forgot the quote. All right, good stuff. Okay, let's
Boom.
try to
Worked
this one.
perfectly. Let's get it wrong. And the if statement is matching up those decimal numbers with reasonable precision, which is really, really good. Okay, common errors you might get in this. Well, the most obvious one is this. This is the most common error we get. This invalid syntax error is because we haven't actually finished the brackets on line 1. But look where it tells us the error is. It tells us the error is on line 2. And this is a common problem that we get when we're combining lots and lots of brackets together now. Just remember that on each line, where there's an open bracket, there must be an equivalent closed bracket somewhere. So in line 1, we have 2 open brackets and only 1 closing bracket, meaning the problem is there. Where the brackets are placed does have meaning, so please don't just throw them in willy-nilly to see what happens. Try and use your logical approach to working out where they should go. Casting is saying, take what the user types in this bracket and turn it into an int or a float, whatever we're looking for. And then we can do mathematical comparisons to it. Why was the error in the wrong place then? Well, as far as the interpreter is concerned, that line hadn't finished. Line 1 extended onto line 2, and then something weird happened in line 2. So clearly the system is trying its best to guess where that error could be. You've got to be mindful of that. Oftentimes the error will be in just the wrong place entirely. Always look at the previous line just in case you've missed out brackets or quotes that could be causing it to think that that line runs on forever. As usual, if you want another extension activity, I've broken some code and placed it in the REPL for this. Go and fix it if you want a further challenge.
All right, let's see if we can fix this here. Okay, you got a 60. Oh, what's this now? All right, let's see what the difference is between ours and the answer. Okay, I have a space here where I don't need it. That looks like the only difference. So I'm gonna actually just take theirs out. Go here and try to run. Okay, let's say I got a 75. Oh, still getting that same error. Got it. Not an int. There we go. Oh, it would be an int because there's no decimal. Not supported between. What did I do differently? Int input. Okay, this is missing an equals. Okay, 75. Line 4 now. It would be less than, right? Is that right? No? Okay, so else if 70. Aha. We don't need quotes for our number. Okay. Like I said, it's just really what I've learned the most is just a lot of attention to detail. Okay, so 75. Acceptable. All right, let's do it again. We got a 60. Dude, you need to study more. Okay, that worked. Awesome. All right, so now we'll move on to the
Challenge for
challenge.
today. We're going to work with a person's age in years, and we're going to tell them exactly where they sit in terms of the type of generation they are. Personally, I'm a millennial, but we've got this list of generations and the years in which they were born. We would like you to ask a user to type in the year they were born, and from that, identify which generational group they belong in. Please share your project with us in the community with the publish button and on social media, and make sure to hashtag it with replit 100 days to code so we can all see what cool stuff you've been getting up to. Day 10 tomorrow, we're going to try taking the fact that the computer now knows.
Okay, so now let's check this out. Okay, so generation generator, we've got what generation are you a part of? So here's the list. We've got the names, which would be traditionalists, baby boomers, Generation X, and millennials. We've got the starting year and the ending birth year. Let's read the hints. Think about what inequality symbols you need to use. You will need to use and the closing when you look at the range numbers, and then you'll use an if or int in this project. Add emojis or a fun statement to go along if you like. Okay, so here's the sample code. And let's break it down so that we actually understand it. So we've got our birth year with an int because there's no decimal point, and that is equal to the input is what year you were born. Now, if the year was before 1946, you would say they're a traditionalist, and that's because the ending year of traditionalists was 1946. Then we keep going on. Then we use an elif statement here, and if it was before 1947, which is the starting year of baby boomers, and then we also add in if it was before 1964, we would say, hey, baby boomer, how are you doing? Next, we would go to 1965 to 1981, and that's Gen X, what's up? Then we would move on to Generation X. I'm sorry, we just did Generation X. Next, we're looking at millennials, 1982 to 1995. We would say millennials, the age of tech, the best. Okay, and then we would do greater than 1996 to 2015. It would be Gen Z, TikTok much, and then anything outside of this scope, we would just simply say try again. So very simple, but good use here of the ages with the table. So we'll hit run, make sure it works. I'll use my age. Cool, and that actually worked. So let's hit run, and just for fun, let's do 2023, and that worked. Anything after 96 is going to say TikTok much. Okay, now what if we were to try 1922? Hit run again. All right. So we'll try one for each just to make sure that it actually works. Now we'll try 1947. Okay. And 1965. And 96. Okay, cool. So we know that that works. Add emojis or fun statements to go along. We're just going to use the examples. This is really just the reason that I do this is not really to get that creative. I just want to understand why these things are working the way that they do, because obviously we're trying to learn the foundational skills of Python. So, I mean, we could mess around with that here and add, like funny stuff, but there's not really a need to do that. And that's it. So
Knows that we are using numbers and introduce it to a little bit of math. But don't worry about it. We'll get the computer to do the math for us.
that'll be tomorrow, which will be day 10 already. So awesome stuff. All right. Next we will. Today, let's actually do this. Let's take a screenshot. We come here, day 9 of 100 days. Day 9 of 100 days of Python. Okay, we would want to deploy the project. Now we'll publish our work. Tag it as Python and fun. Leave the icon as it is. We can add our cover photo. Where would that be? It's just that screenshot. We'll just leave it. Okay, so there it is. That's published. And we will hit mark this lesson as complete. And there it is. Okay, cool. So I'll just drop this link or I'll drop this tweet underneath this live stream. I'm sorry, post under this live stream. And I'll be back for tomorrow, day 10. Thanks a lot, guys.